Okay. Hi all. Good evening. My name is Symeon Foskolos, and I'm the product manager for Karoot. And today we will take a brief look inside the tech that moves people. So, can we have a raise of hands to see a little bit which one of you has used a ride-hailing application before? Okay, good. So I see a lot of users. So today, as I said, we are going to see what happens after you tap the Find the Taxi button. So in ride-hailing, there are two realities in this ecosystem. We have the technical side, of course, where we have matching and dispatching algorithms running in a backend system architecture. We have payment and verification processes. And of course, everywhere in between, we have analytics, crashlytics, and live monitoring of trips. So every single tap triggers a chain of microservices and decisions literally in milliseconds. Beginning from the way the app itself is built, apart from the safeguards, let's say, implemented by the platforms themselves, and I mean, of course, iOS and Android, you have to have in place a third-party protection. You have to keep this in mind against reverse engineering and tampering. And so once this is covered and the request is made, we capture the user's location, the ID, his trip preferences, and the request is sent to our backend. So once the request hits our API gateway, firewalls, load balancers, and virtual machines that are running the code, queues, database, and file systems are all engaged so that we can respond. And on screen, as I talk, you can see, again, a small portion of the API that is implemented both for driver and passenger in order to be able to handle both requests. And of course, a counter of the backend calls that we have per hour in a normal, let's say, in a normal hour of operation. So as you can understand, it's a pretty complex system. So again, let's see what happens once this API request reaches our backend. We have, at the heart of Karoot, let's say, we have a real-time intelligence engine where geospatial indexing meets real-time driver locations and their tracking. And we continuously index every active driver that is currently on the map. And so the system can instantly identify the closest drivers, calculate accurate ETAs, and this is very important, and adapt dynamically as drivers move around the city. In Karoot, we have a proprietary cost algorithm, so we can ensure that we have transparent and balanced pricing by factoring distance and time. At the same time, passenger preferences are also, such as pets, Wi-Fi, or in-car chargers, are all matched to drivers who offer those options, and the system also continuously adapts these driver assignments to optimize availability, satisfaction, and efficiency across our platform. So, also to get another brief example, If we see that some drivers, we dispatch the request to some drivers and we see that those first batch of drivers did not respond, our second request factors in new drivers that may not be so close, but have a higher, let's say, percentage of accepting the ride. So we transfer the call to them first, and then we retry with the previous drivers. So again, this is another example of how we try to adapt with this changing real-world scenario. And of course, we have a lot of notifications running for the driver. We have to update him if the passenger moved from his location. We have to have, again, messages that we will see later on to make their communication easier. So again, there must be a system in place where those notifications are serviced in a very quick way. So once the passenger sets all his preferences and he sets his preference as his pick-up and drop-off location, we immediately come back with a cost estimation, of course, his payment and pick-up point, and also we must generate again an estimation of how long it will take for the driver to come pick him up. So once the request is made, and again we dispatch this request to the driver, and the driver accepts, it is then that the trip is assigned to him. The passenger is immediately notified that his ride is on the way. The passenger can monitor his location and the routing of the taxi in real time on the map, on the passenger application. The driver, of course, is again navigated to this pickup point, and we have constant update of the ETAs on both applications. Now, communication in the real urban environment, let's say, is crucial. So we have two solutions, let's say, implemented. So we have an IVR implementation where the passenger and the driver can call each other, of course, with call masking, so they can communicate over the phone easily, find each other on the road, and also there is messaging in place so that they can exchange brief messages to facilitate their communication and to find each other on the street. So once the arrival of the taxi is again confirmed by our system on both the driver and the passenger application. Now, if it happens so that the passenger overshoots his pickup point, the system will update again both states, in passenger and driver, and the approaching process will reset with current data. And this also has to happen within milliseconds. While we are on trip, the driver again uses the navigation feature to reach the drop-off location. The passenger can again monitor the trip on his passenger application. And of course, we generate a link that is available in the share button that you see there. And this link, when used in any browser, can show in real time again as the trip happens, so someone else can monitor the trip and make sure that you are safe. Once the driver arrives at the drop-off location, again, the arrival is confirmed by the system in both passenger and driver applications. And of course, once the trip is done, this is one of the most critical parts, let's say, of the process, the payment. As you can all imagine, an application like that has to cope and has to be prepared for a lot of scenarios, like insufficient balance, invalid cards, switch from a card to a cash payment method, and vice versa. You have to integrate with Google Pay and Apple Pay, and all this is extremely important that it works flawlessly, because at this point the passenger has opened the door, is ready to go out, and you must be sure that you will not create any problems, let's say, any delay in his everyday routine. And now, let's go and cover the problems of the real world. So, you have to account for things that are extremely difficult to model with code, let's say. So you have driver and passenger behavior, human behavior, the urban reality in which you operate, of course, and trust and incentives. As we say in Karoot, again, before every API call that you make, there's a real person making a real live decision. Let's talk a little bit about urban reality. So we have traffic congestion, unexpected road incidents, strikes, changing weather conditions that continuously affect our fleet's availability, passenger wait times, and overall system performance. These real-world variables, again, are really hard to let's say, cover and predict with code and algorithms. We operate in a dynamic, human-driven landscape, and adapting to these external factors in real time is essential for, as you understand, for maintaining the reliability, trust, and of course, user satisfaction. Trust and incentives, another difficult puzzle that we have to solve, and to tell you the truth, we haven't solved it yet, but we are trying. So you have to have incentives that appeal to both, and sometimes incentives that might be appealing to passengers act as counter incentives for drivers, and again, vice versa. You always have to have both sides in your mind where you design everything, so that you can figure out the better solution. The passengers now. Of course, in Greece, in Thessaloniki specifically, where we currently launched, we operate in a highly competitive, highly regulated market against tech giants that are also well-established players in the market. We have to engage customers, we have to win them over, bring them on our side, but we also have to be prepared for bad actors that in our case, can seriously impact our brand. For drivers is the same. We have to, again, engage drivers to go online, accept rides, and be ambassadors and support our brand and our vision. While doing so, as I discussed, another problem that we have to solve is growth management. So what do we mean by growth management? We have to design a sustainable growth through smart incentives. Either we reward engagement, rides completed, app engagement, loyalty earned, or whatever we might think. We have to ensure that every euro that we spend drives measurable and data-backed revenue growth. Again, as we say, every euro that we spend must move the needle somehow. Support, also a key factor in having a successful ride-hailing application. So, when we are talking about someone using a ride-hailing application, we are talking about someone that might be missing their flight or an important appointment. So everything is, as far as support is concerned, also is super time sensitive. Everything has to be resolved quickly and accurately. Apart from a passenger that might have an issue, a bad actor on the passenger side might mean that a hard-working individual, a driver, will not get paid for his ride, and in some cases that might account for a quarter or more of what he makes in a day. So you have to make correct decisions, you have to make them fast, and you have to have multiple data points where you get your information in order to make that decision. So, building a ride-hailing app isn't just about technology, it's about connecting people in the real world. Hope you enjoyed our presentation. If you have some questions, we'll be happy to answer them, and feel free to drop by booth 13 to connect. So, Thank you. So, any questions? No? Okay.
Hello.
Hello.
You said earlier there are some cases where you put out a call to multiple drivers and they can accept this call, right?
Yes.
Are there any cases where you specially handle the case where two drivers accept the same call at the same time? And are there any business logic to it?
Yeah. So we use, good question. So we use a different and straightforward, we think, model. So we don't send the call to multiple drivers. So we use, as I said, geospatial indexing. We find the closest one, and we send the call, the ride request to him first. If he doesn't reply within a short period of time, or he cancels, then we send the call to the next, to the closest, the next closest. So in a kind of like round robin, let's say, approach. And for now, we have just a small, let's say, advanced business logic, where, as I said, if 3 drivers, for example, do not accept a ride, and the passenger requests for the ride again, the same ride, we try not to send the ride to those 3 because we know they declined. So we try to find others that have entered the grid, and so we send the ride to them first. Yes.
Regarding the payment,
Yes.
is it taking place when the ride is finished, or can it
You asked when do we charge? Yeah. So also in this area, again, we are different from all the competition. We think it's fairer to make the charge after the trip is done. We think this, let's say, eliminates a lot of issues and problems and a little bit of worry from the passenger, having to keep in mind when will the money will be returned to him if the company charged him more than the actual fare. So we charge when the trip is done. So the flow is that the trip ends, the driver sets the amount in his application, and this amount is communicated to the passenger, and the payment is done according to what the passenger selected. So cash, card, Google Pay, and so on. So at the end. Any more questions? Okay. Thank you very much. Hope you enjoyed it.